All right, so this is your next question from Cat 23 slot 2. You can try it out and resume the video for the solution. So let's observe something. We have two sequences AN and BN. AN, if we observe carefully, has been given as 13 plus n minus 1 into 6, right? So this very clearly resembles A plus n minus 1 into D. And this is the general expression for the nth term of the AP, right? That means AN is an AP where the first term A is 13 and the common difference D is 6. So now we can generate the sequence as first term 13 and then plus 6 is 19. The next term is again plus 6, 25. Then next term is 31, then 37, then 43, okay, 49, so on and so forth. This is your first sequence, AN. By the same logic, we can observe that BN is also an AP. It is of the form A plus n minus 1 into D. So A being the first term 15 and the common difference is 7. So for the second arithmetic progression AP, the first term is 15 and your common difference is 7. So the next term would be 22, then 29, then 36, then 43, then we have 50. The question is, largest three-digit integer that is common to both these sequences is. We observe that the first common term to both the sequences is 43. And now the next common term between both the series will be obtained when the common difference would be the LCM of 6 and 7, the individual common differences. So the common terms between the two APs is also an AP, starting with the first term 43 and the common difference equal to LCM of 6 and 7, that is 42. Right? So 43, the next term is 43 plus 42, 85, then 85 plus 42, 127, so on and so forth. Now for this series, we can clearly observe that every term is one more than the corresponding multiple of 42. So first term is 42 into 1 plus 1. Second term is 42 into 2 plus 1. The third term is 42 into 3 plus 1, so on and so forth. So the general term for this sequence is 42 into n plus 1. And now you want this number to be the largest three-digit integer. So 42n plus 1 should be less than 1000. This gives me 42n is less than 1000 minus 1. And then 42 we divide from both sides. 42 we divide from both sides. We'll get 999 divided by 42. So you can reduce the 2 by 3 or you can use your on-screen calculator also. You can reduce by 3. So 333 upon 14. 14 2s are 28 and 14 3s are 42. 23 point something. So n should be less than 23 point something, meaning n can be at max 23. So the greatest possible term here when n is equal to 23. So we plug in the value of n as 23 in this general term, we get the greatest possible three-digit number 42 into 23 plus 1. So 42 into 23 will basically be 966 plus 1 will be 967. That is the answer to the question.